So a warm welcome also from my side. My name is Christian Dülmer and I'm the representative of the Weidmuller company inside our Smart Cabinet Building initiative. So hopefully most of you are already familiar with our initiative. In today's webinar, we like to change the focus from the initiative overall to our integrated use case, and we would like to show you how easily the different systems of our partner companies can work together. Before we will come to the detailed informations of our integrated solutions, I would like to show you some more informations about the initiative overall. So if we have a look at the challenges of our customers today, we have there several hurdles. For example, increased cost pressure, growing quality demand, lowest quantities, or lack of skilled personnel. Especially the topic of volatile planning, I think, is more than ever before in the focus of everyone in these special Corona times. So we from Smart Cabinet Building ask us how we can help our customers in the best way. And honestly, we are very sure that the best way to help our customers is to combine and bundling the competence and know-how of several experts in the field of cabinet building. So just as a short reminder, we have there 4 partner companies inside our initiative: Weidmuller, Comax, Zucken, and Armbruster Engineering. So what's our overall target? We are very sure that based on these solution offers from these 4 partner companies, we are already able today to provide you integrated solutions from engineering to wiring. And these integrated solutions meet today's as well as future challenges in cabinet building. And one further aspect is very important. For sure, we want together with you identify different optimization potentials along the value chain in your cabinet building. But the real difference is that we are also want to tapping it with solutions that are available today. So later during the presentation, you won't see only some showcases, you will see their machines and solutions that are already in daily operation in several factories. And to make long story short, our target is to enable you to produce faster, more flexible, and more economical. And based on that, we would like to have a deeper look at our integrated use case. And first of all, a short overview. So for us as Smart Cabinet Building, the whole value chain in cabinet building is the most important topic. So we have there solutions for engineering, logistics and mechanics, component assembly, component marking, wire processing, and even pre-wiring, cabinet assembly, wiring and testing. So really the whole process step. You could see there on the slide in the middle, we have the digital twin. And today we want to show you how easily you can come from digital to physical. So how easy you can design a cabinet, and after defining the digital twin, how easy you can make use out of this information and use automated or semi-automated solution to really come to the physical solution in the end. And based on that, I would like to give the word over to Achim Stirner from Zucken.
Thank you, Christian. So let's talk about the digital twin and the way how to get one. So we have as Christian said, in the center the digital twin. From the digital twin, we can export all the data who is needed to these automated and semi-automated processes. But we need a digital twin, and if you are lucky, then you get from your engineering department or from your customer a perfect digital twin designed with EO3 series. If not, I can show you how to get a digital twin by your own based on a parts list and a connection list. Because if we have this digital twin, then we can derive these enormous potential benefits. So, short video. So we can see in the middle, it's all about the digital twin. So if you get a perfect digital twin, like in this case, it's ready. So maybe you have one, then everything is fine. If not, and this is now, I have an empty project and empty sheet, so there's nothing in, no devices, no wires, nothing. And now I can show you how to come to a digital twin very fast. We can use, for example, some templates. In this case, I have a template with the mechanical part of the cabinet, so some rails and cable ducts and the housing. And we see with importing this template, I have some devices and I have graphical representation. And now I import just a parts list. And here it is enough if you have the device name and a component code or article name. And in a second step, it would be nice if you have a connection list from tool list. If there is also the wire color and the cross section, then it's much better. But there's not a must. So I have imported now this device list and the parts list. So I have more components in my trees, as well as some connection lists, and I can place them very fast with the E3 panel. So you can see it's just by selecting the devices in my tree, in this tree called unplaced, panel unplaced. All my devices are in who I have in my parts list, but not placed in my cabinet. And you can see if I place the terminals and these other devices, then the cabinet gets complete. And on the left side, my tree has to get empty. Then I know, okay, I have all devices placed. It's possible to place also some all the components. So, and the red dotted lines, these are the logical lines from our imported wire list. And now E3 can do the auto routing for you. And if I select all the components and do the auto route, then the complete cabinet is routed, the cable fill duct degree is calculated, and now I have a perfect base to export our cutout information. We can export data for labeling and marking. We can export the wires. We have source destination, we have the length, we have the wire end marking, so the pin names and so on. So we have all the data. We don't need any schematics. It's enough to have the parts list and the wire list and place them in E3 panel. And now this is a good base to export all the other data you have in your production. Maybe you have all of them. Oh, sorry. Next sheet. So it's just from the engineering to create, to get or to create, like I showed the digital twin. And then from the digital twin, you can export to various automated and semi-automated production machines, whatever you have. In a perfect way to the machines of the partners of the Smart Cabinet Building Initiative, but there are some more exports to various other machines around the cabinet assembly and cabinet production. And with this, I want to hand over back to Christian.
Yes, so thanks, Achim, for showing us the digital world and how we can easily get to all the relevant information inside the digital twin. The next process step, I want to have a more detailed analysis is the process step of logistic and component assembly. And there we want to present to you two different kind of solutions. So first of all, our solution for automated assembly, and after that, Timo Tessin from Armbruster Engineering will give you also some insights regarding an assisted terminal rail assembly solution. Why we are showing both solutions? Because from our point of view, especially this combination of a roboter for the high running components and of an assisted workplace for the not so in common components is a very good way to meet the required variety of variants in an economically way, which really makes sense in the end. And first of all, I want to show you a little more in detail the assembly robot, and therefore I would like to show you another video. So inside this video, we can see now our clip-on automated rail assembler. So the answer of Weidmuller for the task of having an automated assembly of terminals on rail. The machine has overall 40 magazines for different terminals. And these magazines have a very universal design, which is also optimized regarding some handling points. You could see there on this video that for sure they are very easy, but based on this easiest, we have really there a universal solution in the end. During the filling process, we have there several booking steps to have in each process step the right transparency. The machine is steered and controlled by the information of the Weidmuller configurator. And this Weidmuller configurator is also there an automated interface to Zuken E3. We have there 18 magazine places for pre-cutted DIN rails, and another really advantage of our solution is that we have there a special kind of gripper, which consists of several slices. And based on the slices, we can even handle more complex contours of terminals as well. You could see there also inside the video that we are using their terminals that have already blank markers on it. So our Clip-on Connect A series as a DL version, because from our point of view, for sure, the best combination is to having their rail assembler for the assembly of components and later using a rail laser also for the fully automated marking. But we not want to show you only some nice image video. We want to show that this machine is really operating day by day. And therefore we take a video yesterday at the afternoon, so with a mobile, so no professional video. You saw there on the screen of the machine that we are producing exactly this DIN rail which Achim designed at the beginning. We saw there also again these 40 magazines where we now put on the right components, and after that we just have to press the start button. Then the machine starts with the production process. So terminal by terminal is assembled on the rail. And again, all the required information comes without any manual interaction directly out of the digital twin that we designed at the beginning of our process step. So the robot put all the components on the rail. We are nearly at the final stage. And then the terminal rail is put out of the machine. That was one DIN rail. I want to show you a second example, also from the digital twin that we designed at the beginning. And this DIN rail, you saw it already on the screen, there we have a special setup because only the robot is putting the high runner components on the rail. And you could see that we have on the rail at the beginning a huge gap. And in that area are special components that we will later place with the Armbruster solutions. And that can be, for example, components that are not so common in use, or for sure also components that can't be handled by a robot. For example, they have to be screwed on a DIN rail or anything like that. And honestly, this combination, I already said, for sure from our point of view makes sense, and from our point of view is good answer to have their smart, robust and economical solution to meet really the required variety of variants. Also in the video, you can see again this special kind of gripper with these several slices so that we have really robust handling of the different terminals on the rail. And now we put out the rail again. And now we will come to the process step of the assisted assembly, and therefore I would like to hand over again to Timo Tessin from Armbruster Engineering.
Thank you very much, Christian. Yeah, now we will show the assistant terminal rail assembly with ELAM, with our software. So practically it's 3 parts here. We have the component assembly that we are supporting with our ELAM software via projected working instructions. That means we show the positions of the terminals on the workplace and are also supporting the worker with automatic screwdriver control. The second part is the component marking, where we show the worker the marker positions on the rail and also are controlling the printers to get the markers fully printed. And third and last, we have the accessories, where we support the worker by pick to light system to pick the right connectors, and also lastly we make a picture of the product for documentation purposes. And how this will look in real life, we have a little video that we will show you now. All right, so now we will see how this will look in real life. Every working instructions you see here is dynamically generated, so nothing is pre-built. Everything comes from the export data that we are receiving. And here we can see that the work instruction is generated and will show where you have to assemble the rail. We also are supporting with the screwdrivers, the automatic screwdrivers, so we can give the worker the exact amount of screws he has to assemble. And the worker will assemble the complete rail here with all the missing rails that that before were not be assembled. The next part is the markers. Here we also show the worker where he has to put the markers and that he has to print the markers. You can see here by the projected working instruction that the worker see exactly where he has to put the markers. And in the next step and last step are the accessories. Here the system is supported by the pick-to-light system. He can pick the connectors from the pick-to-light system. Also has to screw them again. Everything is documented here. And we also show the worker via the projection how the connectors should look like. You can see it here. This one would not fix, but this one would fix. So you know how the connector has to look like for your assembly. And at least the documentation where we take a picture of the assembled rail, terminal rail. Yeah, that's about that. We also have our small video from the last fair in Czech, I think that was, that we can watch here. So this is the same as before, but just compressed in a one small case. But it's practically the same. We are seeing the dynamically generated work instructions. We have our pick by light system that's supporting the worker, and we are also projecting the work instructions right on the workplace. Also supported by the electronic screwdrivers. And yeah, step by step, we can go through the assembly. Okay. So back to Christian.
Perfect. So Timo, thanks for showing us the assisted way. Now we come to the next process step, and we would like to show you that after the component assembly, for sure, the component marking has to follow. And also there, we would like to show you at the beginning short video. So also here at the beginning, I like to highlight the rail laser itself. So a machine which can handle DIN rails with a length of 100 up to 1,200 millimeters and 15 kilograms. We presented this solution during the SPS fair, so roughly 1 year ago, and we implemented such kind of machines also during September last year in our own production. Because based on this solution, you can really have huge time efficiency increases up to 90% depending on the length of and complexity of the DIN rail. So again, everything is steered and controlled by the information which comes from the Waldmüller configurator, who has, again, as a short reminder, an interface to Zucchini 3, and we are using exactly the information that Achim designed at the beginning. If we are using the so-called A-series DL, so with the blank markers on it, the operator has to only put the rail inside and press the start button. You see here on the screen that this solution is very universal and flexible. So our idea in these use case is the high runner components are assembled with the rail assembler, the other components with the assisted workplace, and then the fully equipped DIN rail goes in the end in the rail laser, because the rail laser can take care also of components with a very complex contour, for example, or also of components for sure which has to be screwed on the DIN rail. Unique aspect is the image processing inside our machine, but therefore I would like to give you some more details later. So also for the rail laser, we showed that this machine works nicely, but also for this machine, we want to show you that it's real life. And also at this machine, we took some videos with our mobile yesterday to show you that it's really working. So again, we are using the file from the Waldmüller configurator, reloading the file. You might remember this DIN rail from the beginning where Achim showed us this DIN rail already. And now at the rail laser, the operator has to only put inside the DIN rail. For example, these cross connectors were also assembled by a projection of the armbruster workplace. Press the start button, and then the image processing takes care of each marker. So we are checking from several sides the position of each marker on the terminal, compares this position with the position and in the digital twin, and we are doing fully automated the required adjustment to really make sure that we mark directly in the middle of each marker. And you can see here in the video that it's a really high speed marking process, high accuracy, high speed, and also a very good result in the end of the final marked DIN rail. So just the final side. And then the machine will open and we can see the marking result. We have also very good sharpness for these markers, this marking process, and based on our laser source, we can use our standard marking material, so no special markers are required. That was the first DIN rail. We have also a second one. If you remember from the video of the rail assembler takes care of the terminals on the right-hand side. Over voltage protection comes from the armbruster workplace. There we add this kind of component. Also this DIN rail we just put inside the machine, we fix it, press the start button, scan the DIN rail from several sides again, and then the marking process takes place. And you can see that we also are able with our solutions to mark not only terminals, also some bigger electrical components, DIN rail components are possible to be marked with our solution. Here you can see the result. So also there we have all the markers marked as required. And after the marking process, for sure the wire processing follows, and therefore I would like to give the word to Tillmann Hoss from Comax.
Thank you very much. I hope you can see my screen now. Thank you. I would quickly introduce Comax to you. Comax is very well known in the automotive sector. Most of the wire harnesses in cars are produced on Comax machines. In the automotive sector, we talk about high volume of mostly same type of wire harnesses that are being produced. So automation of this process is very likely and happens everywhere. In the control cabinet building sector, we have also large volumes, but the lot size is small. So each control cabinet is individual. And so if you want to automate this process, you need a very efficient way of handling your data, bringing the data to the machine so that you don't have to program each machine for each project you want to process. This is very well known from the mechanical machining sector, where the drilling and the machining is fully automatic and no manual programming of the machine is necessary anymore. So from the broad Comax spectrum, I want to introduce you 3 topics. One, a very quick look at a typical Comax machine that can produce mixed wire sequences. And then the next step, where we can not only produce wire bundles in sequence, but also directly do the connection to terminal blocks or other connectors. And then a tool that is very helpful for manufacturing environment where you don't have the full data available, where you have to enrich your data to make a real machine readable connection list. So let's jump into this. A quick theoretical excursion in the beginning. Why is it so important to have one data source that you can use for all your process steps? This is very instructive. Often you see a manufacturing setup like this. So each process is in a sequential row. You have to hand over your work piece from step to step, and very often it's also done just by one person who is bound to this one project. Now you can, optimize each process step, which will help you to save time. But the big gain is when you start to execute those process steps in parallel, when you are able to break up your process chain into individual steps that can start simultaneously, because they are all drawing their information from one source of information. And this then really gives you an advantage of up to a 65% reduction of lead time. So when all information are available, you can already assemble your terminal blocks, you can cut your wire ducts, you can start assembling all your components, and in parallel you produce the wire sets, and the fully automatic production of wire sets saves you 50% time, even if you have to enrich your data. And then when you get your wire sets nicely bundled by functional groups, for example, they're all marked with target and source information, so just a trained operator can easily wire up your harness, your control cabinet without making failures. This saves you up to 80% of wiring time. So that's something that everybody wants to have, but the precondition is to have a machine readable connection list. In the ideal world, like Achim Stirner from Zuken showed, that you made your engineering in 3D, you can derive all your data from there and export it very nicely to all the subsequent process steps. Very often we see that, unfortunately, this is not the case because the engineering does not take care that all production relevant data really comes with the digital twin. So Comax has created here a small tool where you can take a photo of your control cabinet. This control cabinet is calibrated, so you have the dimensions. And then you pick your connections from your connection list, and you can quickly draw the connection on your PC screen. And the skilled worker is very, very quick on this. And you can also, you have some rules behind it. For example, that only the signal lines are going on the left side and the power lines go the right side. And you see now here in this connection list that the length has been added to it. And you can here also add missing data, for example, the connection type. Is it a ferrule or is it a ring lock? Or you can add the color and dimension of the wire. And also this, you can treat batches of wire at the same time. So you can very quickly enrich your data and then be ready to send it to the machine, to the Zeta machine, and get it produced for you. And it will give you the bundles in a way that it's most easily to wire up your control cabinet. So this is actually state of the art. Many companies are doing this or going towards this. In our use case, we want to demonstrate more. And for this, I start a video. Quick remark, I mean, we have seen now that the engineering was done in 3D. From there, we could configure the terminal rails. The terminal rails were produced fully automatic on the rail assembler. They were marked on the laser marker. And now we get them on the machine. And here we can wire them up fully automatic. Sorry, now my voice is back. Here, as I mentioned, we see that it is engineered in 3D. We get all the information for the terminal blocks, and we transfer the data to the machine. So there's no programming on the machine done. Here we have the wire processing, 36 different wires on the machine, cutting to length, printing target and source information on each wire. Then we have on the machine different wire end processing possibilities. In this case, we show the ferrules. We can apply different ferrule types on the machine. And here we can produce mixed sequence. Here it gets really interesting. That's the part where the wires are sorted in sequence, how we want to do now the wiring up of the components. The interface. I saw I was muted. I hope you could hear my last comments. So fully automatic wiring up of those components. And this is also possible for small lot size because there's no programming done on the machine. So this is, in our view, a very efficient way to take the next step in automation. I mean, many people still hope for a robot who is doing it fully automatic directly on the panel. But we see that there are a lot of hurdles to overcome this. Maybe in the future it's possible, but here we show a way how it can be done today. And all those components that cannot be assembled on the machine and wired up on the machine, they can be very easily be done on a assisted workplace like we see it from ARM poster, where you get by software the instructions how to do the job. Okay, this was the part of wire processing, and with this I would like to hand over to the final steps of control panel manufacturing.
So then I will continue with a small introduction for the next step. It's the assisted mounting plate assembly. So if we have our digital twin, it is possible that we can export the necessary data for the ELAM system to create the assisted information. So we know all the components who are needed, and we know also the sequence how they should be mounted on each other. So this is also only one click for the user. I can show in a small video. So as you see, it's our digital twin. Exactly the example with the rails we have produced on the various machines. And E3 knows which component is mounted on which other component. So this is a hierarchy, as you can see in the tree on the left side. For example, here the power supply is placed on the mounting rail number 3, and it's very easy. I just click my mother, in this case the mounting plate, and then press a button to export to LM. And now all data for this mounting plate are collected and sorted in a intelligent way with all the necessary data of the position and the naming and the component code and some additional information like descriptions or hyperlinks to other documents. So this is all done in an useful sequence. And with exporting this XML file, I hand over to Timo, and he shows you how this XML file gets imported in ELAM.
Thank you very much, Achim. Yeah, now we are looking at this case in the real life again. Now we have the finished exported data from the Suken software, and we will import that into the ELAM system. And here we have a short movie. Okay, so now the order number is scanned and the working instruction is shown. Again, this is fully dynamically generated, nothing prepared in before. And here we are going step by step through all the assembly parts, and we are projecting them again, like in the terminal RAM assembly, directly on the mounting plate, and are also supporting the worker with a pick-to-light system, so that he knows exactly what part is next and where he has to take it out. And with the projection, he can see where he has to put the part back and where to assemble it. Yeah, and this goes through the whole working process, step by step. The worker gets the dynamically generated working instructions, and at the end we are also making a picture of the product for documentations, and basically that's it for the mounting plate. So as you can see here, it's similar to the terminal rail assembly, but this time it's for the mounting plate. And with that, I will give the word back to Christian.
Yes, so thank you very much, Timo, for showing us the world of the assisted mounting plate assembly. Last but not least, we want to answer the question where you can find more informations. You can get in contact with us directly for sure and ask some further questions regarding our use case. Also there, the hint that for sure we have not only this webinar, we have also several other webinars. So regularly, each last Wednesday of a month, you can get more information about our activities. We will have there some sessions where we all want together present you an update on the smart cabinet building overall activities, and we have also there some technology deep dives where you can find more information in detail for one of the aspects of one of our partners. And based on that, we would like to say thank you for your attention. And the question is if there are any questions so far. Otherwise, I think we really like to say thank you for your time. Thanks for your interest. There's one question. I wonder what additional licenses are needed on E3s for import and export. Maybe, Achim, a question which you can answer. Huh?
Yeah, but some of the exports needs a license. The most of them are for free. So if you are interested in some special exports, please contact me, and then I can tell you if there is a need of a license or not.
Okay, there's also Gianni Canevari with a question.
Yeah, the wiring cockpit is still available, but due to reduced time, we did not show it today. If you are interested in a presentation, I can show you if you want. Please contact me personally by email or phone, and then I will organize an additional presentation for you.
Gianni, I think in this meeting, it's only possible to ask questions when you write them down due to some technical restrictions. So Gianni is typing. I think, okay. So there is a question. How can you really computing the wire length and cutting them before assembling, measuring the medium axis of the channels? I think that goes also in the direction of Komax and Sucken. Achim Tillmann.
Yes, Achim, I think I can answer the question for you.
Mm-hmm.
I mean, you can define an extra length. For example, you can define that you want each connection to be 10% longer or a certain amount of centimeters longer to be sure that you won't have a connection that is too short. If this was your question. Okay, good.
Okay.
You can do it for all the wires, or you can just do it for individual connections. So there are different rules that you can apply for your whole project or just for individual connections or bundles.
So if we don't have any further questions, then again, we all like to thank you for your time. Thanks for your interest. Hope you enjoyed the session and you really see that based on our smart cabinet building approach, you can have integrated solutions from engineering to wiring. And based on that, we would hopefully see you and hear you during the next webinar. And based on that, we would like to thank you again and have a nice day. Bye-bye.
See you. Bye. Thank you.
Bye. Thank you.